All right. We're here 2022. Every year there's a graph question. Every year there's a table question. So these are like really important, and they're questions you can definitely get points on. There's no bagel here. You're going to get it. Number 3. And again, you're either going to find area or find the derivative, and you're going to work with number lines. It's going to be okay if we practice this. So we're given a point. This is the derivative of a graph. The point for it 3. And we're given the derivative from 0 to 7. And we have a semicircle and 2 line segments. And we're going to go from there. All right. So could you find f at 0 and f at 5? And what would that mean? What would the setup look like? So to find that value, we start with what we know, which is f at 4 equals 3. So we start with 3, and then we're going to integrate from that number 4 to whatever I'm looking for. So I recognize right away it's flippity-flipped. So because the bigger number is on the bottom, whatever number I come up with, I'm going to change the sign. Easy. So from 0 to 4, I can do this. So this from 0 to 4 is a semicircle. So that area is pi. The radius is 2 squared divided by 2. So normally that area, because it's below, would be negative 2 pi. But because it's flippity-flipped, it's going to be positive. So it's 3 plus 2 pi. And that's it. You have your answer. The second one is going to be similar. Let's see if I have room here. I'll do it up here. So same setup. So we start with what we know, which is 3. And then we integrate from 4 to what I'm looking for, which is 5. So I just want to go 4 to 5. So 4 to 5 is right here. Now, what's tricky here is that it doesn't tell you what that value is. Man, I need an equation for that line to make sure I know what the value for 5 is, so I know the height. It doesn't have to be complicated. The slope of this line, rise over run, it goes up how many and to the right how many. So it goes up 2 and to the right 2. So that slope is 1. And if I take the x coordinate and then the y coordinate, that's an equation for that line using the point 40. So the slope is 1, and I'm using the point 40 and just writing like a tangent line. So if I plug in 5, I can see that the value is 1, which is what it looks like. So this is 3 plus 1. Wait a sec, make sure I did this right. So the slope of this line, does it tell you what the answer is? 5? Oh, let's try this again to make sure I'm doing it right. Because they said it's 1/2. Oh, I know what's happening here. Duh. So let's focus. So this is 1. That tells me the height. So this is 1. This is 1. What's the area of this triangle? Duh. 1 times 1, half of it. The area is not 1. The area is 1/2. And that's your answer. So 3.5 is your answer. Done. All right, part B. Find the x coordinates of all points of inflection. So which derivative gives me points of inflection? It's the second derivative. So we're going from 0 to 7, but I want to know the second derivative. So I need to know decreasing, increasing. So from 0 to 2, it decreases. From 2 all the way to 6, it increases. And then from 6 to 7, it decreases. Okay, so at 2 and at 6 are the x coordinates of the points of interest because the signs are changing. And then justify your answer. So at x equals 2 and x equals 6 are points. Oh, let's write it down lower. At x equals 2 and x equals 6 are points of inflection because the second derivative changes signs at those numbers. So you say what you're looking for. I was looking at the second derivative. I was looking for sign changes, and you have it. Part C. Let g be that function defined by this. On what intervals, if any, is g decreasing for this? So to understand if something is decreasing or increasing, we have to take the derivative. Let me do that down here. So first of all, let's write down what the function is, and then what is the derivative of this. So it's the derivative of f of x minus 1, and then we make it equal to 0, and then take the derivative and solve it. So I take the derivative, I make it equal to 0 to find the critical numbers, and when I solve it, I add 1. So I'm looking, where is the slope 1? And so the slope is 1. We found it right here, right? From 4 to 6. See, I got that. All right, so here, let's try it this way. So instead of equal to 0, take the derivative to know where it's decreasing, right? Make it less than 0. So instead of equal to 0, if I make it less than 0, where it's negative, add 1, you're looking where on the graph is the slope less than 1. So from 0 to 2, it's less than 1, and that's it. And also the slope here, sorry, from 6 to 7. So from 0 to 2 and from 6 to 7, it is less than 1. Less than or equal to. So that would be your answer. From 0 to 2 and from 6 to 7. That's where the derivative is less than 1. Everywhere else it's positive, again more than 1. And if I look here, yeah, anyways, I'm going to go with it. Part D. For the function g defined in part C, find the absolute minimum. So that's again a table of values question. So for part D, I'm going to do a table of values whenever I see absolute minimum or max. For g, we have x and g at x. What are the critical values for g at x when I do that? So when I think of this derivative in terms of it, where is it decreasing and where is it increasing? So you take the derivative and you subtract 1. So as this goes down and then increases and goes down, right here the values go down, and then everything else the values go up and then goes down a little bit. So the very beginning when it goes down in value and then it goes up, at 2 is where we're looking at for the lowest value. And then to know what that answer is, we would go f at 2 minus 2. using that equation. So the function value there, we just do 2. So if I did 2, you start with 3, and it goes 4 to 2. So that's a quarter of a circle. So instead of negative 2 pi, half of that would be negative pi minus 2. And so negative pi minus 2 would be the lowest value there of the graph. All right. Mr. G Math over and out. I'm looking at the answer key as I'm doing it, making sure that I'm trying to explain it to the best I can. Each part, so we really are focused on parts A and B and doing our best in parts C and D to get the points we can get. I'm super proud of you. You're getting better and better in calculus. I see it.